So to recap the things we talked about here, first we talked about strings and how you can combine them. So if we say like the letter D plus plus string.fromInt6, that will give us the string D6. If we have a let expression, we can say let x equals 5 in x times 2. We can put as many different values as we want inside that let expression. The entire expression evaluates to what comes after in. We saw some stuff with lists, in particular list.map, which is a useful way to transform a list of one item into a list of other items. So we saw how we can use that with numbers, with strings, and even with virtual DOM nodes. Also, lists have to have a consistent type, which prevents runtime exceptions that can otherwise occur. And finally, we saw partial application. We saw that when we call pluralize passing leaf and leaves, that gives us back a new function which accepts the final argument that pluralize wants and sort of finishes the job. And as we'll see later, partial application and list.map and things like that can be pretty useful together. Any questions about any of this before we get to the exercises? Yeah.
Some kind of somewhat related generic questions on some of the stuff. Like, so list.map, I'm just curious what, some languages will have a generic map. Mm-hmm. And in Elm, everything kind of has its own.
Yes.
I'm just curious what's the difference or decision there?
Some languages will have a generic map, whereas Elm has like a special purpose one. So this is really a question of like name resolution. So in some languages you'll have, like syntactically, you'll just say the word map, like you won't say list.map or set.map or whatever the data structure is. In both cases, they have different implementations under the hood. They may have been arrived at using different amounts of code sharing, but fundamentally, if you're going to have a map function that works on a list, you're going to have a different map function that works on a set because those are different data structures. In Elm, the way that sort of the style that's encouraged is to write everything out explicitly and say like, this is a list.map, it's going to work on a list. This is a set.map, it's going to work on a set. Whereas in other languages, they have different name resolution mechanisms that potentially let you just say map, and then maybe you're passing it a set, maybe you're passing it a list. But it may be even in the same module. But basically, the reason for this is it's sort of has to do with sort of like the design sensibilities around Elm. So as an example of like Haskell is a language where it's a different design sense. Like in Haskell, it's encouraged to only use map, and Haskell supports that. Elm's compiler is written in Haskell, but Evan decided to go a different direction than that.
And then, so like under the hood, a list. Does it actually compile to something in JavaScript that enforces that the types within it are the same?
No.
Is that what we said? No, it's just the compiler knows, okay, I have already checked, so it can just be an array under the hood.
So the question was, does Elm's compiler actually emit something that verifies in the compiled JavaScript that the contents of the list are all the same, or is that only a compile time check? It's only a compile time check. However, it does not actually compile to literally a JavaScript array. It compiles to a linked list, an immutable linked list in JavaScript, which is not represented as a plain JavaScript array. So it has different characteristics as far as like how expensive it is to add things to the beginning versus the end versus like looking something up in the middle. So that's just like an implementation detail that matters from a performance perspective, but not from a like how you actually use it. If you're just worried about like will things break or not, the compile checks are enough.
Yeah. So are there any things like that it compiles to where like newer language features or something are gonna like? I'm just kind of curious, like if browser target is a thing that we would ever want to care about with Elm, because we would get like less or something.
Browser target is a thing that you would care about with Elm. Sorry, I don't quite follow.
Like if it compiled to some newer language feature in JavaScript that was better or something.
Got it. So right now Elm targets mostly ES3. Like it compiles to ES3 compatible JavaScript. It doesn't, with the exception of I think there's like request animation frame and some stuff that's like ES5. But the question is like sort of in the long term, like do you have to worry about like Elm compiling to stuff that's not backwards compatible, et cetera? Honestly, I wouldn't worry about that with JavaScript. However, Elm is explicitly designed to compile to WebAssembly someday. WebAssembly is not really like ready for it yet. It still needs like a garbage collector and some stuff like that. But like we've been talking with Mozilla folks like on several occasions about like how that would work. Not only is it designed to be able to compile to WebAssembly, but it's designed to be able to compile to WebAssembly with all of your existing JavaScript interop continuing to work. JavaScript interop, not WebAssembly interop. So the idea is that based on the current design, you could, in some release, download like a patch release of Elm where now Elm compiles to WebAssembly and everything's just absurdly faster and smaller. But all of your existing code still works exactly the same way as it did before, including your JavaScript interop. So backwards compatibility is something that Elm takes pretty seriously as far as like browsers go. And generally the design is to try and make it as compatible with as many older browser features as possible, sort of by default, and not to use like any newer browser features unless there's like really no alternative to get that particular thing done.